Well, thank you very much, everybody, for joining. Hope today will be a fantastic session and it will be quite useful. If you have any questions, do not hesitate to put your questions into the chat. I'm reading chat constantly. It is on my second screen. And what we're going to talk about today is UML. We'll start talking about it. And as any other topic, you will you can become familiar with UML very quickly. You can start using it very quickly, but in order to master it, it will take time because it is necessary not only be aware of notation itself, but also it is necessary to know some approaches how to use it. So what I want to share with you today is a set of very basic things or very basic approaches which you could use to document your decisions and document your code. So, as ordinary, if you're here for the first time, my name is Alexander Barmin and I'm Chief Software Engineer. Currently, I'm located in London, United Kingdom. Also, I have a couple of AWS certificates. And if you have any questions, do not hesitate to contact me directly on Teams or by email. I will be happy to help. And well, as a tech lead, I have to document my decision quite often, right? And to be honest, we have many different notations. We have, for example, of course, we have UML, we have BPMN, which is very good for documenting business processes when you need to design a sequence of steps. We can use PetriNet for designing some processes and simulating them. Also, we can use quite old but still useful notations like IDF for modeling our for modeling something in a functional way. And there is an ERD notation which is used for designing the database. So in common, there are many different notations. And what I'm going to share with you today is UML. UML was invented many years ago by a group of people from rational software. So first of all, what is UML? UML is actually an acronym which means Unified Modeling Language. And initially it was designed for modeling everything, not only for designing software, but primarily for designing software. Unfortunately, it is not so widely used in any other area. It is primarily used in the software design. So many years ago, in 1991, it was a company called Rational Software. If you're old enough, you may remember software like Rational Rose or IBM ClearQuest or what else was included there, or IBM something, I don't remember the name. IBM has quite tricky names to remember. So Rational Software tried to help developers to share their knowledge on the one hand, and on the other hand, they tried to to come up with a language which allows to share understanding between developers. Because when you're just telling something, it is one level of understanding. If you can also show a diagram before writing a code or before doing something, you can you may be also it also may be useful. So in Rational, a few people were hired. It was Grady Butch, Emmanuel Rambo, and Jakob and Ivar Jakobson. And they were asked to develop a unified language. And in 1994, 1995, this unified language was invented. It was called UML. Next language was adopted by Object Management Group as a standard, and now in 2005, a second version of language was released, and it was published as an ISO standard, which is also good. In common, UML includes many different diagrams. UML2 because initially there were something like 12 diagrams. UML2 includes many diagrams, and they can be split into two big groups: structural diagram and behavioral diagrams. So structural diagram, on the one hand, explain structure and set of components which should be included into the system. Like you can explain the system as a set of components, as a set of deployment unit, as a set of packages, as a set of classes. And on the other hand, you can explain behavior of your system, how the system behaves in one or another way. For example, in what sequence you should call your services, what states your main business entity can be in, what different use cases are supported by your system. So many different diagrams and many different aspects. As I said, my topic is called PlantUML in practice. So let's move to the practice, because I suppose practice is more interesting. I prepared a few diagrams, and these diagrams explain one single use case from different perspectives, from, as you may see, from 8 different perspectives. Let's assume that you're coming to a bank and like to get a debit card. I suppose all of you have a debit card. And in order to do it, you as an applicant need to go through different states, right? So first of all, what you're doing, you're asked by a bank employee for a particular information, like they're asking for your name, first name, last name, date of birth, source of income, and so on. And actually what we're doing, we're collecting this information. As soon as this information is collected, what's happening next ordinary is that this information is validated. It is necessary to check that first name and last name you provided is not something like Ivan Ivanov or John Smith, but it's something meaningful, and you're not on the list of persons who are prohibited to open accounts in the bank. The same is checked with your income details and address as well. And if everything something is not okay, you will be rejected, or maybe you will be asked to collect more information. So as a customer, you again getting back to the collect information stage, and next your information is validated. If everything is okay, you may need to go to final crime checks, and if everything is okay, your application approved, and your application is created, and now you're a customer of a bank, right? This is the process, how we can explain it in words. But on the other hand, we can express this process in form of diagram. And as you may see here, I'm using PlantUML for drawing. As any state diagram, it consists of states. One state is actually a box. And between states, we can have transitions. And this is actually it. You can use state diagram for designing your process. It is very good for designing your, let's say, business process in terms of states and transitions between them. What we can help you when we design it using PlantUML. In order to do it with PlantUML, we unfortunately have to write some code, right? We need to define states. We may define states in advance. It is not mandatory, but we can do it by saying state, name of the state, and declaring as alias for the state. In this case, why aliases? Well, of course, it's quite clear, but here we're saying this is state, this is name of state, but why do we need aliases? We need aliases because when we declared our states, here I declared my states, next I need to declare transitions between them. And it is also possible to use names here, like collect information and collect information here, collect information here. But as you may see, annotation doesn't allow me, PlantUML doesn't allow me to do that. That's why if I have a space, character in my state name, I have to declare it separately. As you may see, I fixed it, collect information, and now it is working. But without it, it is not working. It is just a trick of PlantUML you should be aware of. Another useful trick which PlantUML allows me to do is to have nested states. Like here on the right-hand side, I'm checking during the validate information state, I'm checking multiple things, check 1, check 2, check 3. So that's what I can do is I can declare states within states. Well, there is a quite interesting thing. If I have a state within state, I can of course can declare an entry point here. So saying like when I'm starting, but I need to change it a little in order to have it. Let me show. Well, this way. Validate information. Validation start and this one. Validation start, validation PIY check, because first one is PIY. Validation start, validation PIY check. Well, anyway, so what it allows me to do is to declare a start and end point within my state. So within my state, I can have multiple. Within my state, I can again have a starting point and end point, finishing point. But also, which is very useful in PlantUML, is that I can declare it in a bit different way. I can say that, well, this is an entry point into my substate, and I have multiple exit points from my state. And in order to do it, I have to use syntax of PlantUML by declaring this here. Here I'm declaring this is entry point, this is exit point. And by having these markers, I will have small circles here on the border line. And also, as you may notice, I can make my diagrams a little prettier just by using color coding. So if everything is okay, it is green. If everything is not okay, it is red. Useful, relatively useful. Well, speaking about disadvantages of this approach is that it's a little inconvenient to write long lines. You have to use this /n symbol in order to have a word wrap, in order to start a new line. But anyway, let's say finishing this section, you may notice that using state diagram is quite useful when you need to describe a state machine. Well, any questions?
Yeah, one question.
Of
So
course.
you can color some boxes with the colors. I'm curious, is it possible to generate a legend for this diagram using PlantUML? Because sometimes it is needed just to highlight what does it mean, the coloring.
Well, I'm not aware about this functionality, to be honest, because I have never come up to this idea. But what I know is that it's possible to add the title diagram, like here is my state machine. Yes, it works everywhere, title, yes. But I'm not aware of capability to add a legend. Yes, you're right, it would be very useful. To be honest, I went through PlantUML website many times, and I have never faced an example with a legend, unfortunately. It has never been presented there, so I have never seen how to do it. But that's a good point.
Thank you.
Yeah, good, very good. Well, let's move forward. So if we take a look into this process, you may notice that actually I'm collecting 3 kinds of information, right? I am collecting first name, last name. I'm collecting information about address. I have something which validates my person, and I have something which orchestrates it, right? Are you still following me? Are you still here with me?
Yeah.
Good. Well, that's good. That's why let's move forward. And by having this understanding that I have multiple components in my small system, I can say that, well, my system consists of multiple components. Let's assume I have a customer detail service, which is responsible for collecting information about which is responsible for collecting personal information. First last name, last name, and so on. I have a service which collects information about address, and a service which is responsible for validation and orchestration. So it's a good way to represent this kind of structure. And of course, the service have to communicate to each other. And so that in order to communicate, they have to publish some API, and other services have to use or consume these APIs. And what we can use components diagram, which shows components of our system. Main important point here is that, of course, I'm not saying that this is the one single option to use components view or components diagram. Because what I'm showing here is that my components are actually big applications. As you may see, Spring Boot up. In modern world, it is something like a customer details microservice or address details microservice or application microservice, right? It is possible to go deeper and describe smaller components using components diagram. For example, I have a component in my code, which is, let's say, a service, and the service is talking to some DAO, data access object, or some repository, and on the other hand, the service is used by controller, REST controller. It is still possible to use this kind of diagram in order to represent these relationships. What I want to show here is that we're able to declare components and also declare some APIs which are published and consumed by these components. And of course, we can nest one component into another. Right here, for example, I declared my components and they are child within bigger groups. This set of components, this set of services is deployed in Kubernetes, this service is deployed to OpenShift, and this service is deployed to Docker Swarm. So as you may see, by having this diagram, I have a bird's eye view to my system. Useful, isn't it? I think so. Let's take a look into the PlantUML representation. PlantUML representation of it is very similar, but a little different, as ordinary. There is a quite interesting thing in PlantUML that PlantUML uses very similar syntax for different kind of diagrams, and it is very confusing because in one diagram you may notice here we're using just brackets and another kind of brackets, and in state machine we're using not only brackets but brackets and asterisk inside, right? But in component diagram we again using different syntax in order to represent different diagrams. So what I want to say is that it is necessary to be very, very, very attentive to the syntax you're using. Because in the opposite case, instead of having, for example, component diagram, you can have a deployment diagram. So speaking about components, as you may see here, I have three high-level components. Component Kubernetes, component OpenShift, component Docker Swarm. They have different colors. We have already learned it from the previous example. And inside components, I'm putting another component. And in order to declare a component, I'm putting its name into the brackets. This is customer detail service in the brackets. And again, I can declare an alias in order to solve the problem with spaces. And also here I can add a stereotype saying that this is actually a Spring Boot application. I can write anything just to highlight type of my artifact. And of course, what I can do is I can add color coding of any kind I want, but it is again necessary to put it into the proper place. Will it become red? No, it is not becoming red. Let's put it here. Yeah, so as you may see, it is sometimes tricky to find the proper place and it requires some experimentation. Well, this set of lines allows me to declare only components themselves. And what I'm doing here, I'm declaring their interfaces. As you may see, I have brackets at the beginning and name of component and alias. Again, the same pattern, but with different beginning. Here, component, here again, brackets, and here just open close brackets. But it will not work without last one part. If I get rid of this code, what we will see is that actually what I have is just components and their interfaces. They are independent. And what's next I want you to show is how to connect components to their interfaces. It can be done relatively easy, relatively simple, and this pattern is used in different diagrams, in other diagrams as well. I am adding arrow of dashes, but by default, PlantUML tries to distribute boxes on the diagram on its own. And as you may see, by default, it is not always doing it effectively because, well, actually, I can see all the diagram at once, but unfortunately, for example, right now, my lines are crossing. I would avoid it. So what I can do is I can say that on that customer API component should be put up to application service component. So I can say that up, down, and try to help. I can try to help PlantUML to understand what exactly I want it to draw. And as a result, as you may see, I'm getting a bit better diagrams, which does not have any line crossing and so on. Well, another important point, which is very similar to previous diagram and which is used everywhere here, is you can add some labels for arrows. As you may see here on the right-hand side, I'm using a semicolon. I'm using colon to separate this relationship with this comment or label on top of it. And another important thing to highlight here is that instead of using just arrows, I can use half spheres by adding this, just by adding this opening bracket. So as you may see, if I'm putting an arrow, icon is replaced with, sorry, not icon, but arrow is replaced, line ending is replaced with arrow. If I am putting an opening bracket here, it is again replaced with, let's say, with a sync, with consumer. Well, is it useful? Are you still here with me? Any questions?
No questions so far.
Good.
No questions. So just one like that parenthesis there that is used for asynchronous. If you know, you have the publish to customer API and then that goes to Docker Swarm, and that indicates that it's going to be a synchronous operation. Is that correct?
No, we're just showing that the services are talking to each other, unfortunately. It is not so, yeah. So it is just showing, well, well, of course, UML have different kind of arrows, and every arrow supposed to have different meaning. And if arrow is solid, it is supposed to have a meaning that communication is synchronous. It means that application services wait until customer detail service responds. But we can express, we can use UML convention and say that my application service will not wait. So I need to replace my solid arrow with not dotted. How is it called? Please help me.
Spaced? I don't know.
Okay, with spaced arrow, with spaced line. Yeah,
Dust.
and dotted or dotted line. Yes, and it says that this is something like an asynchronous communication. We may not wait until this communication completes. Yes, that's true. So anyway, we can we have different lines here, and of course we can, if necessary, we can express different, let's say, kind of relationship between between components. We can say that, well, this is not only consumes, but let's say it uses in any way. So if you take a look into a UML specification, you will see that there are many different kinds of arrows. It's on the one hand, it is they allow you to express different meaning. On the other hand, it is quite confusing if you're using them all, and it is more confusion if your team is not aware of that. So from my perspective and from previous experience, it's better to use some common set of arrows and put very meaningful explanation what it means, like use in async way. So here I'm saying that I'm not only using, but using in async way. So that's tricky, I understand.
Great, thank you. That was really nice explanation.
Yeah. So personal recommendation, if you're using something, please put notes, because in the opposite case, first of all, you can forget about it on your own, and you can bring your colleagues into confusion. That's true. Moving forward, as you may see here, I have Kubernetes, OpenShift, Docker Swarm. It looks like I can deploy my services in 3 different clouds, right? And put something on premises. And there is a special way of representing it. Let's say I can use a stereotype. If we take a look here, my stereotype actually is component. But here I'm allowed to say that I would like to use a different stereotype for drawing different icon, and say this is cloud. And I have a connection between clouds using, for example, Direct Connect or VPN. Well, very high level, right? Are you still here with me? Good. But of course, I can go deeper and say that, well, inside my cloud, I'd like to deploy my services. And inside the cloud, inside AWS, I will deploy my application within autoscaling group. Within my autoscaling group, I will have a set of EC2 instances. On every instance, I will have a Docker Swarm worker node. And here I will deploy different components, component and artifacts. So this is component, this is artifacts. And these components will talk to each other via something which is in the middle, for example, pipeline or queue. And it will talk again to a different frame, to the different set of services which are deployed to a particular node. So how can you use it? We're again moving deeper into our system and expressing the same information, but we're designing a system which allows us to onboard new customer, but from different perspective. Right now, we're talking about this system, but from perspective of deployment. Here we can say that, well, I have components and they are nested in the following way. And on one component, I deployed one artifact. On another component or another node, I'm deploying another artifact. Approach for designing it is very similar. As I said, I'm using different different icons or different stereotypes and declaring groups. And I'm nesting one group within another. So as you may see, within AWS group, I have 3 services, which are database as RDS and 2 queues. And also within AWS, I have 2 another groups with nodes. If you take a look into the PlantUML website, you will see that there are different stereotypes, but these, for example, stereotypes are the most widely used for this view, for the deployment view. And again, within instances, I'm again declaring my artifacts and my components. Well, any questions, comments, complaints, regrets?
No.
Good, because you may have already noticed that actually on every diagram we're talking about the same set of components, like application service. We have already seen application service here. We have already seen application service here. But is it the same application service or not? And unfortunately, if you're using only PlantUML, it is not possible to say that is this the same service or not. But if you're using a tool like Archimate, for example, or Rational Rows by Rational Software, it allows you to build not only UML diagrams, but also build a set of connected diagrams, which allows you to traverse across your software and see it from different perspectives. For example, if you're using Archimate, it would be possible to click on, let's say, this application service, and Archimate can provide you with information that actually the service is used in 20 more diagrams. Would you like taking a look into them or not? But today is overview for UML. Maybe next time we will talk about Archimate as well. Are you still here with me?
Yeah. Sounds
Good.
nice.
Yes. A few diagrams left. No worries, no worries. We will finish soon. Sequence diagram. You may have already seen this sequence diagram, but it is quite complicated to understand how to use them, right? Because when you need to explain this class talks to this class talks to that class, it is not very useful because it is too detailed. But right now we have microservices, and microservices are very good at communications. We're talking to each other in order to get us very simple things. Like if you need to get current time, you need to go to a separate service which provides you current time. That's why there is something like a sequence, there might be a sequence which shows in what order services need to communicate in order to provide a particular feature. And here I'm showing, for example, again, the same business process, but from different perspective. What I'm showing here is that what should happen in case if a customer would like to provide information about its own, like first name, last name, date of birth, or something like this. Well, on a very high level, our client, mobile client, web client, goes to web server, and web server returns back a single page application. And next, our client using this application sends data to something like a web application which receive requests, or let's say backend for frontend or API gateway. We can easily rename it. Let's do that. API gateway, or orchestration app, or something, or even anything else. So, but API gateway. Let's put it here. So let's put it here because API gateway sounds meaningful, quite meaningful. So what's happening next? API gateway next sending request to customer service. Customer service does something, or maybe in case if data is not valid, it will return a particular error, or if everything is okay, the service will record data back to the database and emit a message to a particular topic. So this diagram is very useful when you need to demonstrate how your components are interacting. Of course, it is not possible to create one single diagram which explains all the interactions at once. And common recommendation from the common sense is that to create separate diagrams for separate, let's say, for separate cases. If you, for example, have a separate use case which say, I am providing information for the first time, and this is a set components which are involved in it, or I'm updating my existing information and another set of components is involved in it, the better create two diagrams? Well, because having PlantUML, it is not so complicated to do that. Again, approach here is very similar. I'm declaring my participants with different using different archetypes. This is an actor, so that it is displayed as a weird human. These are participants, which are just boxes. This is database and queue. And next, I'm saying that actually these parties are exchanging messages. And in order to send a message, I'm just putting an arrow here. This is an arrow which says that, well, I'm sending a message. And of course, different kind of messages are different kind of errors are available. I can say, for example, it will be a very, very solid communication here, or it will be a message to my role, like something like a validation, or if I'd like to put a note, I can use this note syntax. It is the notes can be added to almost any element of a diagram, and but unfortunately have a little different syntax in different diagrams. But nevertheless, it is quite useful for explanation. And here on sequence diagram, I can say that actually different flows are available here. There may be exceptional cases, there may be different flows of execution. So if you need to show that there are some alternatives, you can use this alt keyword in PlantUML. So in common, any questions regarding using the sequence diagram and use cases when it is useful? Have you ever seen in your practice cases when it would be useful to use a sequence diagram?
Sure, it's kind of pretty common type of diagrams for such purposes.
Yeah, indeed. The main word you said is for such purposes. So it is, as I said, the main complication in UML is that you have many diagrams and you need to match your diagrams you have and purposes you will use it. And if you find a good, let's say, good situation, then you can use sequence diagram. That's very good. That's why I'm saying it's very easy to become familiar with it, but it requires a lot of time to use it. And you will spend all your time just by trying to find a case when you need to use one or another type of diagram. Good. Let's move forward. If you remember from the previous diagram, from state machine diagram, our application can be in different states, right? But, well, it is not very, it is not always possible to say which of these checks, for example, are happening in parallel because, well, state diagram is not a very good way for representing it. On the other hand, we have another kind of diagram, which is activity diagram, which is intended to be used for designing processes. Like this, let's say, is action and next decision. This is action and next something is happening in parallel. And again, we have a kind of diagram which was called block scheme diagram, or maybe scheme of algorithm diagram. And the closest diagram by meaning in UML is activity diagram, because it shows what should be followed by what, and what checks should be performed at a particular point in time. So here, as you may see, I'm expressing this logic that I'm checking something in my application. And if something is not present, I have a decision point or a junction. And based on the decision made, I go to the left or to the right. And it's possible to go in third direction as well. So very good diagram for expressing different kind of decisions and expressing different alternatives. Diagram itself is quite simple, and as you may see, it is very easy to start drawing it, but you again need to be super attentive to the details, because if you start drawing it with another kind of brackets, you will get state diagram instead of having activity diagram, because as I said, PlantUML is very, very attentive to the symbols you're using. But in common, rest of syntax is the same. You're again declaring your start point, and here you do not need to declare states in advance, because here the spaces are supported in this type of diagram. And next, you're just saying that if everything goes fine, then this is the branch I will go. If not, I will go here. And again, here you can express even parallel execution of something. Again, as you may see, I'm showing the same process, but from different perspective. On the state diagram, I showed that I have multiple steps, and in a particular state, I'm checking a particular piece. And here I'm saying that in what exact sequence it is happening and what else is happening. For example, I'm throwing an exception somewhere here. And of course, it should be possible to use color coding. As you may see, it works. And it is possible to add nodes. It is not very convenient, but it is possible. Still here with me?
Yeah.
Okay.
Yes.
Okay, good, good. I'm just checking that you didn't fall asleep.
No.
You know, just a couple of diagrams left. Yeah, I'm trying to do it as practical as possible. And well, actually, all these examples are built based on real examples. Unfortunately, I cannot show you examples from my customer, but actually, I'm drawing regularly the same set of diagrams. Well, what can I do next? It would be nice to go deeper and try to represent something on the next level. For example, I can use class diagram in order to represent something which is more complicated and which is something which is more software specific, right? For example, I can use class diagram in order to design my database or design my domain area in terms of entity classes I'm using, but I also may use it to represent some technical decisions. Because, you know, in order to design database, we have another notation, which is ERD and the entity relationship diagram, and it is quite good at designing. But unfortunately, this diagram is not, ERD diagram is not very good at designing correlations between classes. So that we can have a class diagram, which is really good at it. And on class diagram, we can, for example, express the situation when we have a validator, for example, name prefix, and this validator actually uses name prefix repository, which is abstraction, which is interface. And for this interface, we're going to have multiple implementations. And having a class diagram, we can express it. What we're doing as ordinary, we're declaring our components using class keyword or class archetype and declaring a properties inside by using properties different markers, let's say plus, minus, we can declare both public and private fields. Please pay attention here to the name prefix. This is my name prefix. I can say that, well, name is public now and it became green. But also, as you may see, name is property because it is on the top part of my box. If I'd like to declare a method, what I can do, I can say this is a get name method, and by having this opening and closing brackets here, PlantUML understands that this is actually a method. If I remove it, PlantUML will understand, well, looks like it is a property. very tricky, very tricky. You need to be very attentive to it. Well, that's simple. I'm declaring my classes, declaring properties, declaring methods inside, and what I'm doing next. Next, I need to connect all my classes using proper types of arrows. And in order to do it, what I'm again doing, I'm putting arrows. I'm drawing arrows using pseudographic, and also I may help PlantUML to align diagrams, align components in a particular way. For example, here I'm saying that name prefix repository should be upper than name prefix JP repository or Mongo repository. So that, as you may see, they are behind. They are behind. They are below name prefix repository. Any questions?
No.
Good. By the way, it's very useful diagram when you try to explain to developers that you have to have multiple implementations, and it is very useful for explaining business that you will have multiple implementations so that in case of changing, for example, data source, you will not need to rewrite your main business logic, which is here. And you may say, well, this is a layer of abstraction we're ordinarily talking about. This is here. It is a long, big class in the middle. Useful. Well, okay. Last one piece, last but not least, is use case diagram, which allows me to show responsibility for which actually can be used for many different things. But if we're talking about software, and we can say that we have different kind of users, like actors. And these different kind of actors allowed to use in our services different kind of operations. And here, using this diagram, I can clearly present that I have my customer service, and within this customer service, I have 3 use cases or 3 operations, which I can next explain using, for example, sequence diagram, using activity diagrams. But nevertheless, on this diagram, I'm showing that 2 operations here are available for my client, and another operation, third one, is available for operator only. So here I can connect features which are available, which are provided by my services to the users or to customers or to clients which will use it. I suppose that's all regarding this diagram. Any questions, comments? What's your experience in using it? Have you ever used it?
No, this one, I've never used it. And to be honest, I've never seen it at all in real projects.
Well, it is quite, yeah, I understand. It is quite hard to find the proper situation when you need to have it. Because in most cases, this diagram is ordinarily replaced by a table. This service provides these features, or this service has this endpoint. But if you'd like to make, let's say, a slideshow or deck for someone, maybe it's better to use a diagram because it is much easier to read it than table. But as I said before, it is easy to be familiar with diagrams, but it's quite hard to find proper use cases when you can use it. So, and to be honest, that's all. That's all what I wanted to show you today, because you have already seen that UML is quite a good tool for modeling software. You can design it, you can explain it from different perspectives, from functional point of view, from deployment point of view, for implementation point of view. And again, you can use all these diagrams. It is not mandatory. Nevertheless, they all are very useful in particular cases. The examples I've shown you today are available on my GitHub as ordinary by this link. Thank you very much for listening.
Thanks a
Any
lot.
questions?
Thank you. Thank you for the presentation.
Thank you.
By the way, from your perspective, what are the most useful diagrams? Because Or what notations do you ordinarily use?
Well, for me, UML